So thank you so much, everyone, for joining us today. My name is Holly Kinnis. I'm a conservation analyst at the Municipal Institute. Joining us on the call today as well is Ken Sanderson, who is our GIS and web developer, as well as Stefan Price, who's with the town of Cochrane. Hello, Stefan. And then also Amanda Legros, who's also a planner with the town of Cochrane. And Stefan's with the geomatics department there. So as we were just laughing about, Zoom always, you'd think we'd be used to it by now, but it always throws us for a few loops. So I'm just going to do a quick webinar tech overview. So we'll be recording today's presentation. We'll be posting it later on our YouTube channel within the next few days. So if you have to jump off early, you can always check it out there or send it to any colleagues that might have missed the presentation. So you are muted by default. Now my videos are in the way. There we go. We'll use the Q&A function for questions. And I think we're going to save all questions for the end of the presentation. So we'll address those at the end. So feel free to pop them in as you think of them, and then we can kind of like bundle them together in the end as well. We'll use the chat box for any comments, or like I said, you can include what municipality you're with in the chat box if you want to share that. Make sure that when you are using the chat box that you have all panelists and attendees selected in the chat so that we can see your comments clearly. So the Mistaki Institute is a nonprofit charitable applied research institute, and we're affiliated with Mount Royal University, and we're located in Calgary, Alberta. We do research that is accessible to communities and decision makers so that they can make choices that promote healthy landscapes. The Mistaki Institute's office is located in the traditional territories of the peoples of Treaty 7. However, our conservation work takes place on many different traditional Indigenous territories. We acknowledge all of the many First Nations, Métis, and Inuit whose footsteps have marked these lands for centuries. So thank you again to the town of Cochrane, Amanda Legros and Stefan Price, who contributed greatly to the making of this guidebook and to allowing us to kind of have them be our guinea pigs for this process for creating a natural infrastructure asset spatial layer for the town of Cochrane. Creation of a comprehensive inventory of municipal natural infrastructure assets is one of the first steps in the management and valuation of these assets and the services that they provide to us. The idea behind this project is to help municipalities create a spatial resource and database using best available data, and then allow municipal users to self-identify the ecosystem services in which they are most interested, and as well as the natural infrastructure assets that support those ecosystem services. The services that we focused on are related to flood and drought mitigation to increase municipal resiliency to a changing climate. This guidebook is freely available now on our website and is generic so that each municipality can tailor it to create their own inventory. So since 2018, Mistaki has been working to help municipalities increase their flood and drought resiliency. We've worked on a variety of projects such as the Municipal Flood and Drought Action Planning Primer, the Municipal Eco Toolkit, and the Working with Nature Toolkit, which we had piloted with the town of Cochrane. Our process for the Municipal Natural Infrastructure Asset Inventory project included several steps. The first step was a literature review. We found that some Canadian municipalities and organizations such as the MNAI, Municipal Natural Assets Initiative, you might have seen their name mentioned if you've started digging into some of this work, have already created inventories for municipalities across Canada. From our research, we created a list of natural infrastructure assets and ecosystem services specifically related to flood and drought. Natural infrastructure is defined as strategically planned and managed network of natural lands such as forests, wetlands, and other open spaces, which conserves or enhances ecosystem values and functions and provides associated benefits to human populations. The term natural infrastructure is sometimes used interchangeably with green infrastructure. However, an important distinction between the two is that natural infrastructure could be considered a subset within the broader category of green infrastructure. For the purposes of this project, we have broken down green infrastructure into 3 categories of natural assets: fully natural, enhanced natural, and engineered natural. We have excluded other types of green infrastructure, such as solar panels, water meters, for example, because we are specifically focused on the green infrastructure that would be considered fully natural or enhanced natural. This table depicts which assets contributes to each flood and drought related ecosystem service. You can see we have a few engineered assets included in there as well, such as green roofs and green roofs. And so just depending on the availability of data, that can kind of reflect if your municipality decides to include that or not, or what your goals are for your inventory. So our next step, we developed a natural asset framework that outlines a step-by-step process for creating the inventory. We worked with planning services and geomatic services within the town of Cochrane as an extension of the pilot project, working with nature. We created a 5-step methodology that could be followed by other municipalities interested in creating their own inventory. So examples from the town of Cochrane are included throughout the guidebook. Included in this framework that we've put together is a process for evaluating each asset's contribution to flood and drought ecosystem services, as well as a broad assessment of the current condition of each asset, which sometimes can set us apart from what some of the other inventories have done by other municipalities and organizations. And if you've dug into some of the literature on creating inventories, it's quite varied by the approach that everyone takes. And the way that we've developed this guidebook is that you can tailor it to your own needs and your own goals from a municipal perspective. So the final step in the process was the creation of this guidebook to support municipalities through creating their own inventory. The methods described include specific instructions on what data are available in Alberta and recommendations on how to use this to create your own inventory. So the first step in the framework is to identify natural infrastructure assets. So like I said, this was completed during the literature review phase of our project. We then acquired the spatial data sets. So here's just kind of a list of the data sets. This obviously will be included in the report as well, so you can go over it in a little bit more detail, especially for those of you out there that are GIS specialists. I'm sure you'll want to review the methods in detail. So we'll share the report link in the chat a little bit later on. We then identified the land cover base layer and extracted natural assets. So for this step, we assessed 4 different land cover data sets and found that for the town of Cochrane, the most accurate data set was the AAFC annual crop inventory. We then extracted the land cover classes data from the crop inventory that best represented the natural assets, but we excluded classes that were better represented in other data sets, which brings us to our next step, which was building the additional natural infrastructure asset layers. So these are the additional layers that we had more accurate data sets for. And so we went through a process to build each of these layers. So riparian, wetland, lake, large river and small rivers / streams, urban trees, and stormwater ponds. And if a municipality had a list of their green roofs or had those in some sort of a spatial context, this would be where you would include that layer. So lastly, we integrated all of the asset layers to create the overall natural infrastructure asset inventory for the town of Cochrane. This resulted in the following asset types. The specific methods on how we integrated these layers is included in the guidebook, and it was done in a sequential process. This is the resulting spatial representation of the natural infrastructure asset inventory for the town of Cochrane. The inventory is meant to be a living data set, meaning that as development occurs or as natural infrastructure assets are added or restored, the data set should be updated. To assess the contribution of natural infrastructure assets to flood and drought across the study area, we assigned a low, medium, and high value to each asset for different ecosystem services. The values were assigned based on research review and expert knowledge. These values could later be modified based on emerging research or other new information. The values were 1 being low value, like low value contribution to that service, to high, which was scored as a 3. When a specific ecosystem service did not apply to an asset, it was given a value of 0 for not being applicable. And like I said, for each of these ecosystem service evaluations, they're all, the process that we went through is all detailed in the report. This is the resulting layer now with the values assigned. So high value for flood and drought related ecosystem services are in green, a medium value is in blue, and the low value ecosystem services are in yellow. We then evaluated each asset's condition based on 2 metrics, patch size and human disturbance. The value of the 2 metrics per asset were summed to create an overall value ranging from 2 to 6. So 2 being the poorest condition and 6 being the best condition. As you can see, much of Cochrane's natural infrastructure is in good condition, which is displayed as green on the map. Gone are the days when municipalities can assume that natural infrastructure assets will provide the ecosystem services without the need for planning, management, and maintenance. Natural infrastructure provides ecosystem services critical to flood and drought mitigation, as well as additional services that cannot be provided by gray infrastructure, services such as recreation, cultural and historical value, mental health, and biodiversity. Although natural infrastructure cannot provide all flood and drought mitigation, the multitude of services it will provide can support many municipal goals simultaneously. A first step in considering natural infrastructure is to build a business case to support investments to protect and restore natural infrastructure assets. To build a business case, a municipality must know what natural assets they have and where they are. This project seeks to assist municipalities by identifying a 5-step process for creating a municipal natural infrastructure asset inventory, that's a mouthful, of your own. The resulting natural infrastructure asset inventory is provided in a user-friendly format for planners and other municipal staff and can be adapted for viewing by the public or for other presentation to municipal council. So that can be, some municipalities have put that online as a web database, or you can keep the inventory as an internal resource as well. So I think Ken is going to put a link to our guidebook in the chat for you all. So I encourage you all to please have a look at the guidebook, which can be found on our website, rockies.ca. We'll put up the link here in a minute. So that's in the resource library on the reports page. And then I'll also be sending out a link to all webinar registrants as well after the webinar is complete. If you do have any questions related to this methodology, please reach out to us and we're happy to have a conversation about it. This work was generously supported by Alberta Environment and Parks Watershed Resiliency and Restoration Program. And I will open up the floor. I wanted to keep the presentation short and sweet. I know that Zoom fatigue is real, so I wanted to keep it short and sweet. Here is myself and Ken's contact information if you want to reach out to us after. And if you have some questions, throw them in the Q&A, or you can raise your hand and I can even open it up if you want to verbally ask your questions. And on the call today, we have myself, Ken, Stefan and Amanda to answer any of your questions. And once I stop sharing here, I should be able to see the questions a little bit better. There we go. Okay. Let's see. Well, let's first, okay, I don't see any questions in the question and answer. So maybe there's some questions in the chat. But while I look through that, maybe I'll open it to Maxwell Kelly, who's raised their hand here.
I must have done that by accident. I actually don't have a question.
Okay, no problem. Okay, so here are some questions coming in. So what are the most challenging aspects of creating natural infrastructure asset inventory that you, like you've outlined? So maybe, Ken, do you want to take a stab at that? And maybe I'll just jump in for a second here and just say that I know coming up with some of the background context of this inventory, when you start delving into natural infrastructure, you'll find that there are a variety of different definitions for natural infrastructure. Some of them align quite well with what you're trying to do. Some of them don't align quite well. So you have to really decide, what is going to be your definition of natural infrastructure, and kind of go with that. There's also, it's still very much an emerging field. So there's a lot of new research coming out on a weekly basis. And so that's why we kind of created this process that you could update things as you go. Like, for example, coniferous trees contribute more to ecosystem services related to flood and drought than deciduous trees. And so that's just based on some new research that's come out. And so if research were to come that, flip that the other way, you could change that evaluation and then later change, the outcomes of what your inventory looks like a little bit. So Ken, did you want to just talk to maybe some of the technical challenges with creating this?
Yeah, I think the biggest limitation or challenge would be lack of access to a real quality land cover class. We used the annual crop inventory as the best we could have, or we found for our situation. But if a municipality or a town had a better one, that would certainly help the process along. I think the annual crop inventory works fine for, say, a larger municipality context. It may not work as great for the trial we did for Cochrane, just because of the resolution of the data.
Perfect. Thanks, Ken. Let's see. So I'll go to the next question in the chat here. So were there key resources you used to inform your report? We use a variety of resources. They're all listed in the report. We looked very closely at what other municipalities in Canada have done for the creation of their own inventories. So I would say we based a lot of the process on those similar approaches. There's been one for the town of Okotoks that was done by Fiera Biological. We looked at that as well. But as Ken said, it also really depends on the best available data that you have. And so sometimes some municipalities have more or less data than others. It's also greatly variable from province to province. So, we relied on a lot of those resources. We relied on a lot of resources from the MNAI, the Municipal Natural Assets Initiative. So they have a lot of great resources on their website as well. And they've taken a slightly different approach to the inventory, but we had looked at that as some of our guiding resources. Okay, so I see a question from Joshua here in the chat. So was there any specific methodology that was used to assess the condition of each natural asset? Was it developed independently or drawn from other sources? So Ken, maybe you can provide a little bit more input on that, but I think generally when we looked at patch size and human disturbance, those are pretty well supported evidence metrics for that condition assessment. Some of the other inventories had looked at the same sort of metrics. So it was, we did look at what existing research was out there for that. Anything to add, Ken?
No, I think you covered it well. We different, like the what is it? What's the name? mRNA. They and the Fiera report, they did it slightly different than what we did. We kind of rolled them up into one human condition or human impact score, but generally speaking, we followed very similar methodologies.
Yeah. Okay, and I see a question here from Joshua as well. So does the guide provide guidance for valuing ecosystem services beyond just flood and drought mitigation services? So unfortunately, it does not. And why it does not is because, like I said, we specifically did this for flood and drought mitigation as it was part of our funding prerequisite, like the program that we applied for is the Alberta government's Watershed Resiliency and Restoration Program. And so that's specifically focused on flood and drought. But you could definitely take the same sort of idea that we undertook for this process and use the same framework just to evaluate the other ecosystem services. So you just have to research, how those would be valued, whether it was recreational values. We did include a list of what the other ecosystem services are that are provided by natural infrastructure. So the list is there. And that's kind of like an agreed upon list from IUCN, from MNAI, from a variety of sources. So that would be a good starting point. And then you could grow your inventory to include those other things. And I just see a comment here in the chat from Lauren. She says she believes that Alberta Transportation has runoff coefficient maps for different areas in Alberta. Not sure if that would help as it has higher data confidence than the resources you've leveraged. Okay, yeah, good to know. I don't know if you have any thoughts on the runoff coefficient maps, Ken. That's good to know. And I mean, there are some resources out there that, we might just not be aware of, or maybe they weren't as accurate as some of the other sources, but thank you for pointing that out. Okay, we have a question from Mindy in the chat. So being new to this, how are natural assets broken up into individual assets? For example, a continuous forested area containing a stream. So Ken, I think that one falls in your wheelhouse.
We basically let the land cover and the various layers that we combined together, all of them were polygon features. And so we let that dictate how they're split up. We did not imprint human footprint into those data sets to split them up further. So if a big road went through a section of forest, it would still be one block of forest. It wouldn't be split into two. Does that answer the question, I think?
Perfect. And I just included the report link in the chat here for you all. So I encourage you to go and check that out. It's going to be a short and sweet webinar. Anybody else have any questions, or do you have questions for the town of Cochrane? Oh, here's a question from Amy. Using that land cover approach, were you able to include assets included in the urban area?
Yeah, the land cover does cover it through the urban area, but we also relied on Cochrane to provide their tree layer, the stormwater ponds. Those are all urban data sets. Any other data sets that included natural infrastructure assets would work. You just overlay them at the end.
Yeah, and I think it's really important to point out that the step 5 in that framework, the integration of all the different layers that we created, that's a really important step, and it really outlines the sequence that we went through to deal with all those different data sets and like what happens if one layer overlaps another, which one trumps the other one, that sort of thing. Okay, we have a question from Shirley. Were alluvial aquifers and active floodplains functions, that's a lot of F words in one, fit into this analysis? Let me just think here for a second. So unless Ken, you want to jump in.
The floodplains was included as part of the riparian data sets, and then the aquifers we did not include.
I think we were having some discussion about soils data. Was that where we maybe had discussed about the aquifers and the permeability of the soils and things like that?
Yeah, it was just out of scope of what we were working on.
Yeah. Okay, I have a question here in the chat for, maybe it's for Amanda probably. She'd love to know how the town of Cochrane staff intend to use this going forward. Maybe Amanda and Stefan both want to take a stab at that one.
Sure. So for right now, we're just updating our data and maps, and we'll hopefully use this internally as an internal resource. And then moving forward, we're hoping to use this data and information to inform policy moving forward as we update our municipal development plan and other statutory documents. So we're hoping to use it as some background information and data to inform those policies moving forward.
Thanks, Banda.
I wouldn't have anything really to add other than to support our planning colleagues in the work that they have in front of them.
For sure. Thanks, Stefan. We did include a little bit of a section as well on how this is relevant to planners and municipalities. And like Amanda said, with the redevelopment of their MDP, the city of Calgary also just updated their MDP, and they have included a natural infrastructure asset inventory within that as well. So we have a link to that in our report if you want to check out what that already looks like for the city of Calgary, as well as some other municipalities. I think city of Saskatoon has done one as well off the top of my head. Prince George, Langley. Yeah. Do we have any other questions? Everyone's reading the report. I know they are. So if there's no other questions, then I might let you all go early. And you can take this extra half an hour that you have to go and dig into the report. Like I said, reach out to myself or to Ken if you want to have a follow-up call or have some questions for us on the methods. And I want to thank you all for joining us today, and good luck with the creation. I hope I see tons of inventories popping up all over the province. So let us know what you think of it. Thanks so much, everyone.